Hey Pre-Calc, this is video 6 for this section. Now we're going to change the value of c. I'm going to add pi over 4, so you should know that then, since it's in the function, it's shoving the entire graph to the left pi over 4 units, okay? So that is so now we're doing the last one. I've done all the other values. That is the c. The c again is a horizontal shift. It moves it left or right. Just a friendly reminder that if both B and C are active, the left-right shift doesn't necessarily look equivalent to the value, because if you squeeze or compress, the graph is not going to sit exactly where you would expect it to sit. Okay, so let's do this one. The B value is still 1, which means that the period is still 2 pi. The function is not horizontally stretched or compressed. It also means the increments are still pi over 2. But the thing that is different is that since you're moving it, the old start is right here where it used to start, and the old stop is right here where it used to stop. So one cycle used to start at 0, it used to stop at 2 pi. This graph, because it's pushed to the left, you can see that the new start, right, the new start will be where x plus pi over 4 used to equal to 0. So the new start will be at negative pi over 4. And you can see that the new stop that used to be where the graph was equal to 2 pi, but if you recalibrate this, you'll get 7 pi over 4 after you get an LCD. And like I said before, the increments are still pi over 2 because the period is still 2 pi, right? Remember, the formula for the period is 2 pi over b, but b in this case is 1 because there's nothing, if there's nothing there, we assume it's a 1. So the period is still 2 pi. So when you do the increment, remember the formula for that is the period over 4. So the period is still 2 pi, and 2 pi divided by 4 is still pi over 2. So for me to get to the next value, I have to add pi over 2, because that's the increment, that's the jump. So if I add pi over 2 to this, I get pi over 4. I jump again by pi over 2. If I add pi over 2 to this, I get 3 pi over 4. I add pi over 2 to this, I get 5 pi over 4. If I add pi over 2 to this, I get 7 pi over 4. Okay? So basically what happens is that you have a new start, and a new stop. As you see me doing the other problems, I tend to call this the interval. The interval where it starts and stops. And how you find the interval is you set it equal to the original stop, the original start and the original stop, and you recalibrate it. There is nothing outside of the trig function. There's no d value, there's no a value, so that means that none of the y values are different. So these all stay the same, and then you would graph this. The graph of this is a tiny bit trickier than the other ones because the reason it's trickier is that from negative pi over 4 to pi over 4, that's one jump. So we're not using the origin. There's no like 0 for x here. We're not using the origin. We're going right from negative pi over 4 to pi over 4. So I'm calling this an increment of pi over 2 right here. So that means that my next jump has to be the same width as that. Right? So you got to just this is a little tricky spacing this one correctly. Okay, so what do we have here then? 3 pi over 4, 5 pi over 4, 7 pi over 4. Same thing going this way. You got to watch the spacing on that because it's got to, be pretty equal. So this is negative 3 pi over 4, and so on. Okay, if this is 3/4 right here, then 1 has to be bigger. So 1 would be maybe like that. All right, so negative pi over 4 is 1. pi over 4 is 0, 3 pi over 4 is -1, 5 pi over 4 is 0, 7 pi over 4 is 1. And then as usual, you make sure that you pull it out. You pull it out more. I won't do that so much this time. You guys know to repeat the points and stretch it out. So this is a graph that's pushed back pi over 4 units. Okay, gang, hope you enjoyed the video. Catch you in another one. Bye-bye.